ठीक है। एब्जॉर्प्शन का एक प्रिंसिपल बता दीजिए, व्हाट इज द प्रिंसिपल फॉर एब्जॉर्प्शन?
Absorption, sir, the basic principle behind the absorption is the mass transfer from the uh, mass transfer from the liquid gas to liquid, sir.
How mass is being transferred?
Sir, in absorption column, the gas is transferred. Gas and liquid are travel in counter or parallel flow. So, due to the concentration difference, the mass is transferred.
Concentration difference of what?
So concentration difference of the solute of which we
Of the solute, correct.
yes sir.
Concentration difference of the solute, depending upon its solubility, the solute will get dissolved in the liquid.
Liquid.
ठीक है। So as you increase the temperature, ठीक है, whether solubility increases or not?
Therefore, generally, if we consider gas as a solute, on increasing the temperature, the solubility decreases.
And in case of solids?
And in case of solids, sir, it is generally non-soluble. Solids are non-soluble in liquid.
You have दूध रहता है आपके पास, दूध में शक्कर डालते हैं आप।
Yes.
हाँ, दूध
So
गर्म
the
कर।
solubility will increase. Sorry, sir.
हाँ, so they are both are in reverse
Yes, sir.
direction। ठीक है। ठीक है, और कुछ बताइए आपके साइड से। तो मैं आपको बता देता हूँ, एक तो क्या है कि आपका थोड़ा पहले इंट्रो थोड़ा इम्प्रूव कर लीजिए। ठीक है,
Okay.
इंट्रोडक्शन है ना, ठीक है, थोड़ा सा उसको इम्प्रूवमेंट कर लीजिए। और दूसरा, पहले वाले को मैं बताया था कि उसने ये था कि प्रॉम्प्ट रिप्लाई मत दीजिए, पहले सोच लीजिए कि आप क्या आंसर दे रहे हैं। ठीक है। तो
Okay.
दूसरा ये है। तीसरी थिंग ये है कि आप प्रीवियसली किसी इंडस्ट्री में काम कर चुके हैं। ठीक है।
जी.
ठीक है? तो फर्स्ट 3 or 4 क्वेश्चंस में भी दे विल आस्क अबाउट योर इंडस्ट्री ओनली। ठीक है। दे विल नॉट नो अबाउट द प्रोसेस, बट दे विल नो द जनरल थिंग्स। ठीक है। सो इन जनरल थिंग्स दे विल आस्क, लाइक इवेपोरेटर है तो जैसे मैंने पूछा स्टीम कप क्या है। ठीक है, वो लोग कुछ और का पूछ सकते हैं। लाइक आपने बताया था फॉस्फेट रॉक क्रशर यूज करते हैं, सो दे कैन आस्क व्हाट टाइप ऑफ क्रशर यू आर यूजिंग। ठीक है।
Yes, sir.
कंसंट्रेशन मैंने फॉस्फोरिक एसिड का पूछा तो आपने बताया 21% मेंटेन करते हैं, उसको हायर ले जाना है तो इवेपोरेटर यूज करते हैं। ठीक है। तो द यूनिट ऑपरेशन विच आर इन योर इंडस्ट्री ना। ठीक है। सो
Yes, sir.
what are those unit operations you identify, and what are the present parameters in those operations which you are using at your industry? ठीक है। and what is the impact? ठीक है। because when
Okay.
अभी आप क्या है कि you are in production ना,
Yes, sir.
you are coming in the shifts only।
Yes, sir.
ठीक है। so you are coming the shifts to daily, you are maybe increasing the temperature, decreasing the temperature, or you are something transferring the liquid, or you are doing some wall operation or something like that। ठीक है।
Yes,
so
sir.
they want to know कि what is the critical thinking of yours, or what parameters you analyze, on that basis you will change the parameters to
Okay.
get the optimum product। ठीक है। so अगर आप एक्सपीरियंस बता रहे हैं that will be helpful for you। ठीक है, you will be preferable because you are from industrial background, but at the same time they will also want to know कि whether you are invested in that industry or not। ठीक है, तो ये आप एक
Okay.
कर लीजिएगा। बाकी अच्छा है। और जो भी पूछेंगे ना उसका थोड़ा सोच के बोलना है। ठीक है,
Okay, sir.
कि उन्होंने जो भी पूछा ना उसको हम सोच लीजिए। ठीक है, क्योंकि वो थोड़ा थोड़ा कभी चला जाता है। जैसे मैंने आपसे सेंट्रीफ्यूगल पंप का वर्किंग मतलब एनर्जी पूछा कि व्हाट एनर्जी इज ट्रांसफॉर्मिंग, तो आपने बोला इलेक्ट्रिकल एनर्जी से मैकेनिकल एनर्जी, दैट इज मोटर टू पंप। आई एम आस्किंग अबाउट
Yes.
द पंप। ठीक है, वो छोटी छोटी चीजें वो ध्यान रखिए। बाकी बढ़िया है, आपको हेल्पफुल होगा आपका इंडस्ट्रियल एक्सपीरियंस।
Okay,
ठीक
sir.
है, और कुछ आपको पूछना है?
सर मैं और कहाँ इम्प्रूव कर सकता हूँ? लाइक टेक्निकल में मैं यही गलती करता
टेक्निकल
हूँ
में
आई थिंक।
वही बताया कि आपको देखो ज्यादा देर का इंटरव्यू चलता नहीं है। ठीक है, 2 मिनट 1 डेढ़ मिनट आप इंट्रोडक्शन में निकाल दो। ठीक है, फिर
जी.
उसके बाद आपका 70-80% चांस है कि आपका जो इंडस्ट्रियल एक्सपीरियंस है उससे वो 4-5 क्वेश्चंस मारेंगे। ठीक है। सो आपने उसका अच्छा आंसर दे दिया। ठीक है, तो दे विल नो कि आपने इंडस्ट्री में काम किया है एंड यू आर इन्वेस्टेड इन दैट इंडस्ट्री. इन्वेस्टेड मींस यू आर जो आप काम कर रहे हैं उस पर आप ध्यान दे रहे हैं. बेसिकली आप इंडस्ट्री बताते हैं ना, तो दैट्स व्हाई दे आर आस्किंग कि वेदर यू आर वर्किंग और वर्किंग प्रॉपर्ली. दे आर जस्ट चेकिंग लाइक दैट ओनली. ठीक है, अगर आपने इतना बता दिया ना, तो अगर आप थ्योरेटिकल थोड़ा पीछे भी रह जाओगे ना, तो इतना कोई बॉदर नहीं करेगा. बट दैट इंडस्ट्री पार्ट यू इम्प्रूव एंड सम दैट पार्ट आल्सो. ओके, और इंट्रोडक्शन में थोड़ा सा ध्यान देना. ठीक है, ओके.
थैंक यू सर.
एक मिनट यार.
Recording stopped.
एक मिनट.
Yes, sir.
हाँ, बताओ.
Hello, sir.
Recording in
evening.
progress.
Sir, my name is Yash Pagare. I have completed my schooling from Cambridge School, Aurangabad. After that, I have done my 11th and 12th from Springdale Junior College. And after that, I have done my graduation from Institute of Chemical Technology, Mumbai, which was from 2021 to 2025. And during that period, I have done the internship with KLJ Group, in which I have done two minor projects. One was the material safety data sheet for ethylene oxide, and a and ongoing in the final year. So for the same plant, I have designed the distillation column for L'Oreal alcohol ethoxylate. And my hobbies are I play badminton. I'm a state level badminton player.
Okay, good. What distillation column you have designed? Can you tell me about that?
Sir, basically this is a L'Oreal alcohol ethoxylate compound. So this is used in surfactants as a foaming agent. So this has a after the product is formed, it is transferred into a distillation column, which is a vacuum distillation column, because it has a boiling point of around 300 degrees Celsius. So we have to avoid thermal degradation. So due to this, we use vacuum distillation column under pressure. So the boiling point will decrease, and we can get the purity of the desired product.
At what vacuum you were operating?
Sir, it was around 3.23 bar, I guess.
3.23 bar is vacuum.
No, vacuum pressure.
3.23.
Sir, I cannot recollect because it was.
You
I
just
cannot.
check on.
Yes, I cannot recollect the exact value.
Maybe it will be 0.23. You 0.323.
Yes, sir. I
Because
cannot
one bar
recollect the
is
exact value.
1 bar is atmospheric. So when you are saying 3.23, so it is above atmospheric only.
Yes, sir.
ठीक है. And when you say आप चेक कर लेना ये, ठीक है.
Yes, sir.
वो गलत ही है. और दूसरा 0.3 बोलना है तो you should say absolute. ठीक है.
Absolute. Okay.
हाँ, जो भी आपका वैल्यू है, that is in terms of absolute, because next question will come whether it is absolute or it is gauge.
Okay.
ठीक है. तो अगर आपने गेज बोला तो वो भी गलत हो जाएगा. ठीक है. So
Okay.
you just check on that. ठीक है, first.
Okay, sir.
ठीक है. Another thing, you said that thermal degradation occurs at that 300 degrees Celsius, है ना? So you are operating in the vacuum. So what is the present boiling point?
After applying.
After reducing the pressure.
Sir, it was around 230 to 235, I guess. और
हाँ.
235 to 250 की रेंज में था वो.
हाँ, तो एक ये भी चेक कर लेना आप. ठीक है, कि
हाँ.
someone knows about it, then he'll ask. ठीक. Okay, whether it was a binary distillation column or how many products you are separate?
Sir, only one product, sir. Binary.
मतलब it was binary only.
Yes, sir.
Binary. Okay. So what was the degree of freedom in that?
So degree of only temperature and pressure were constant.
Temperature and pressure were limited to constant, and the products or the purity of the products were always remained fixed.
Yes, sir.
ठीक है. So consider कि I want to change the concentration of the product. Suppose it
Okay.
was 90%.
Okay.
I want to increase your up to 90. How many trays were there in your distillation column?
Sir, it was a packed column, sir.
Packed column. Okay. What is the height of the column?
Sir, it was a small plant. It was around 15 to 16 feet.
Feet.
Yes, sir.
16 feet. Okay.
It was a small
So,
plant. It was not a big plant.
Okay, no problem. suppose so your product was from the bottom side or product from the top side?
Top side, sir.
Top side, okay. So consider it like that. Ki if you want to increase the purity of your product, suppose it is 90%, and you want to increase up to 95%.
Okay, sir.
What you will do?
Sir, we can increase the reflux ratio.
You will increase the reflux ratio. Means what is the reflux ratio then? Means
Sir,
what is the reflux ratio basically?
so reflux ratio is basically analytically it is L by D, the liquid coming back from the condenser to the distillation column. So it comprises of the more volatile component. So it will help us to get to reach the desired purity more quickly.
Okay. Any other thing you can do?
Sir, I cannot recollect at this moment.
Okay. Think about this whether there will be a multiple feeding point to the distillation column, whether you can change the feeding point of the distillation column.
Yes, sir.
Feed plate can be changed.
Yes, sir. According to how the feed is, if the feed is saturated feed or saturated liquid, according to that we
Saturated
decide.
feed is there, but at what tray you are feeding it, that is also dependent. That curve will
Yes,
also
sir.
change. Okay.
Whether
And also think at least prepare three answers. First is your reflux ratio is correct.
okay,
Second is the plate
okay,
feed point, and third will be the reboiler ratio. ठीक है?
okay, sir.
Because ठीक है, because you have to specify that कि I am not changing any temperature and pressure. I am just changing the flows. ठीक
Okay,
है?
sir.
So you prepare these three things. ठीक है?
Okay, sir.
Because yeah, you have specifically said कि I have designed that distillation column. ठीक है? So don't use that design word. ठीक है? So many questions will come. So you say कि I studied that distillation column and some calculations are done from my side.
Okay, sir.
Because when you say design, it is a huge part.
More detailed process.
हाँ, I have studied the process and some calculations are being carried out by me. ठीक है? And same को हमने acknowledge किया है. ठीक है?
Okay, sir.
ठीक है? Okay. Any favorite subjects you have?
Sir, heat transfer.
Heat transfer is favorite subject.
Yes, sir.
Okay. So how what is the mode of heat received by Earth by Sun? What is the mode of
Radiation.
radiation? How?
Sir, it is by the collision of electrons by which emits electromagnetic waves.
Electromagnetic waves. So can you tell me the reason why these equators are hot but that poles are cold? North pole and south pole are cold, but
Because
the equators are hot.
because the sun the light of the sun cannot reach till that point to emit
Height of
back
the sun
the energy, the radiation, the waves.
cannot reach the top.
It is farthest from the sun.
Why it is farthest? Suppose this is the globe, okay, and this is the sun. How it is farthest?
Sir, like between the equator and the sun, the distance is small as compared to the poles and the sun.
ऐसा नहीं है. Actually, the orientation of Earth is like that. कि it is not this. It is not like that. It is this only. ठीक है?
Okay.
If it is like that only, then the temperature would has been same. You can see the Earth is tilted like that. ठीक है?
Yes, sir.
That's why the equator is getting more heat compared to that of
Poles.
North Pole and South Pole. In that question, you have to tell कि the phase factors. You have learned A1 F12 is equal to A2 F21.
Yes, a reciprocating theorem.
हाँ, reciprocating theorem. ठीक है?
Yes, sir.
तो phase factor of Earth and Sun is not 1. ठीक है?
Okay.
It is less than 1 because of the orientation of Earth. That's why there is a temperature difference.
Okay, okay, sir.
Okay, ठीक है. चलिए इसका बताइए आप कि हीट एक्सचेंजर में suppose there is a shell and tube heat exchanger. Okay, and the tubes, there are thousands of tubes in a shell and tube heat exchanger. And if I want to increase the heat transfer of this heat exchanger, what I'll do?
Sir, if it is shell and tube heat exchanger, right?
Shell and tube heat exchanger.
Sir, we can increase the flow on the baffle side to increase the heat transfer coefficient. Or if we are if we want to increase on tube side, If we are ordering a shell and tube heat exchanger, we can increase the number of passes. If we already have a heat exchanger, we can increase the velocity on the baffle side to increase the heat transfer coefficient.
Okay, but what is the ideal baffle size in a heat exchanger?
0.5 diameter of shell.
It will be huge, na? 0.5 diameter.
Shell diameter
Yes,
or baffle?
it will be huge.
Sir, baffle size.
Yes, baffle length. Actually, baffle length. How much is the?
It's 0.75% of the shell diameter.
So it is actually D by 5. We are using mostly 90% placement. And what will the effect of? You have increased the heat transfer, but what will be the effect on the process?
Sir, it will create a turbulence due to which the heat transfer coefficient will increase as the
Increase.
Reynolds number will increase.
And what will be the drawback?
Sir, higher pressure drop.
Yes, pressure drop will be high. Good. ठीक है. और क्या है हीट ट्रांसफर के अलावा आपका?
सर पंप्स
आपने किए हैं. ठीक है. तो चलो पंप्स में बताओ कि आप how many types of pumps are defined?
Sir, centrifugal pump and positive displacement pump.
Okay, so what is the how you decide where to use what?
Sir, I only know about that if there is a highly viscous liquid, we use reciprocating pumps. And for centrifugal pumps, when we need to create a large pressure flow, we use centrifugal pumps.
थोड़ा उल्टा बोल रहे हो आप. ठीक है. ठीक है. Large flows and low differential pressure, we use centrifugal pump.
अच्छा, okay.
And for low flow and high dp, we are using reciprocating pumps.
Okay, sir. Okay.
ठीक है. Reciprocating or positive displacement pump. There is a reason behind it why we are doing like that.
Okay.
ठीक है. ठीक है. Because in centrifugal pump na, we are converting kinetic energy to the pressure energy. Means
Yes, sir.
two mode of energy transfer is there. ठीक है. While in case of reciprocating pumps, we are directly supplying the pressure energy.
Yes, sir.
ठीक है. तो इसलिए हाई डीपी जहां भी आपको हाई प्रेशर में लिक्विड पंप करना है, you will be using that reciprocating.
Okay, sir.
So what is that relation between that head and means if you want to increase the head of a centrifugal pump, what you will do? What changes in the pump you will do?
Sir, we can increase the flow rate.
No, I want to increase the head, not flow rate. Flow rate suppose initially I was pumping the liquid in up to 10 meter. Now I want to pump the liquid up to 20 meter with same flow. What changes in the pump I need to be done?
Sir, firstly, we have to check that the net positive suction head is positive. So, and if the available pump required head as per the pump is designed should be greater than required. And
No, it is not like that. ठीक है. नहीं है, but what changes in the pump you will do so that it can pump at higher level? Some changes with the impeller dia, n square, d square.
we can increase the RPM of the impeller.
RPM of the pump, not RPM of the pump. ठीक है. Okay. ठीक है. इसके बारे में आप पढ़ना. ठीक है. Basically क्या है कि हम बोलते हैं कि H is equal to n square into d square. If you want to increase the head, you can either increase the speed of the pump or d square, increase the dia of the pump, dia of the impeller.
Yes, sir.
Similarly, there is for the speed also, Q, flow rate is also n cube d to the power 5.
Yes, sir.
So characteristic curves when you learn in
So
there.
yes, sir. Turbulence, to create turbulence, n cube d raised to 5.
Yes. So there is a formula for the head capacity and power. Okay. You just go through it. Okay.
Yes, sir. Q is equal to rho g hp. Power is equal to rho g hp q.
नहीं, वो अलग है. Basically, with respect to it is with respect to pump only. With respect to speed of pump, that is n, and diameter of the impeller, that is d.
Okay.
So head of the pump is proportional to n square d square. Q, capacity of the pump, is proportional to n cube d to the power 5. and power factor is I think ND cube, something like that.
Okay, sir.
Just go through that. बाकी अच्छा है आपका, अच्छा किया आपने, ठीक है। बस जो शुरू में बताया था उसको थोड़ा सा ध्यान रख लेना, डिजाइन पार्ट थोड़ा
डिजाइन
मत
क्या?
छोड़ना,
हाँ,
ठीक है। वो थोड़ा, क्योंकि वो अगर मैंने तो छोड़ दिया, वो क्या है, अगर कोई डीप डाइव कर देगा तो बहुत ज्यादा चला जाएगा।
यस सर।
एंड प्रेशर वाला पार्ट देख लेना है व्हेन यू आर सेइंग वैक्यूम डिस्टिलेशन, ठीक है। तो आपको पता होना चाहिए क्या है वैक्यूम डिस्टिलेशन और व्हाट इज द प्रेशर। इफ यू आर सेइंग यू हैव डन कैलकुलेशन, सो ऑल पैरामीटर्स शुड बी इन योर टिप्स।
ओके सर।
ओके, बाकी अच्छा है, कॉन्फिडेंस अच्छा है आपका, ठीक है।
यस सर।
और ये अच्छा है आपका, क्या बोलते हैं, आपका इंट्रोडक्शन आपने अच्छा दिया है, ठीक है।
यस सर।
ऑल द बेस्ट। बस जो आप बता रहे हो ना, बेसिकली मैंने देखा आपने इंट्रोडक्शन में इसमें एम्फेसाइज किया कि बेसिकली आई हैव डन दिस डिजाइन इंजीनियरिंग या डिजाइन फॉर द डिस्टिलेशन कॉलम। व्हेन यू आर एम्फेसाइजिंग ऑन समथिंग ना, ठीक है, दैट ड्रॉज अटेंशन, ठीक है,
यस सर।
ठीक है। And you are emphasizing something that is sometimes works also. If you're emphasizing on something, then you must
नो
create a
अबाउट इट।
concrete things about it. You know every how and about,
यस सर।
ठीक है। So all the best, बढ़िया है।
थैंक यू सर।
Okay.
Recording stopped.
कौन है अगला यार? एक आदमी आ जाओ। कौन है इसका?
Can I? My schedule was from 6:45 actually.
Recording in progress.
नेक्स्ट कौन?
Uh, my schedule was from 6:45 before the last candidate. So can I?
आप है नेक्स्ट ना?
Yes, sir.
हाँ बताइए प्लीज, हाँ बताइए।
Sir, okay. Good evening, sir. I'm
हाँ
Suraj. I'm from Noida, Uttar Pradesh, and I did my BTech in Chemical Engineering from NIT Bhopal. Where enhanced stability of CO2 microvalve for enhanced oil recovery as my major project. And currently, I'm working as officer trainee in Aarti Industries. I did my summer training from National Fertilizers Limited in ammonia production plant. And apart from academics, I've been an active NCC cadet, earning C certificate, which is the highest level certification for any NCC cadet. And I'm very much eager to contribute and learn as much as possible for IOCL.
no, I didn't get you. What certificate?
C certificate. Basically, in NCC, there are A, B, C certificate. Like for C certificate is the highest level certification for any NCC cadet. That's what I was trying
Okay,
to point out.
okay, okay, ठीक। So whether you have passed out recently, na?
Yes, sir. I
In
passed out in
2024,
2025 itself.
2025 itself. Okay.
Yes, sir.
So what do you prefer? Means do you know about this organization?
So currently I'm working as a trainee. I'm working with PID walkdowns. I did contribute. I was part of the team and Gira team, so I know that much. But actually the production hasn't started yet. So it's actually going for commissioning in a couple of weeks. So I know that much only.
HAZOP, okay, what is HAZOP?
So HAZOP is basically we do a systematic and brainstorming for all the processes and all the operation related things. For example,
What is the
we
full form
assign
of
a
HAZOP? HAZOP, what is the full form of HAZOP?
hazard and operationability, hazard of process and operationality identification.
Hazard analysis of operations. Okay.
Yeah,
Basically,
right. So,
if you are telling HAZOP, then you should know the full form. HERA का भी आप देख लेना, ठीक है? So what do you check in
hazard
the HAZOP?
identification and
So
yeah,
what
so
things you have learned in the HAZOP?
yeah, sir. So basically, we create nodes, which is a smaller section of PNID across the process line, and then we analyze all the factors that can possibly go wrong, and what are the safeguards, what are the possible causes, consequences, safeguards, and we give recommendation along with it, and also we calculate probability, severity, and risk factor, which is product of probability and severity. So
So
basically, it's
whether
a complete yeah.
okay, suppose there is a distillation column is there. Okay. A simple
Yes, sir.
distillation column is there. Okay. And feed point is there. There is an isolation wall in the feed point. Okay. Suppose that distillation is operating at 200 kg per centimeter square. Okay. and someone has asked you to do a heads up of this. Okay. So what things you suggest? What should be there?
So basically there is distillation happening at 200 kg per centimeter square, and there's a isolation valve at field line, right? So firstly, we'll allot parameters. For example, we'll allot flow parameters, temperature, pressure that you're saying, allotted pressure, for example, pressure, okay, right? And then we'll see a lot of guided words like high, low, low, high,
So
high.
for high pressure, what you will suggest?
For high pressure, the isolation valve.
सपोज देयर इज अ कॉलम हाई प्रेशर जा रहा है उसमें, ठीक है, आपने एनालाइज कर लिया कि हाई प्रेशर है, आपने नोड डिफाइन कर लिया, हेजॉप में हाई प्रेशर कैन गो, ठीक है. सो व्हाट इज द सजेशन ऑफ योर्स? हेजॉप
Yeah,
इज द
so
कंप्लीट
basically,
वन. You
yeah,
identify the node, you identify the point, you probable cause you write down, then suggestion you give, ठीक है.
yes, sir.
So
The
I
problem,
have given you the provisional cause ki let it be high pressure. So what
yeah.
will be the recommendation of yours?
So we'll brainstorm on why there is high pressure on distillation column. So it can be that there is it can cause of rivalry is very high. It can be
Okay,
because of
another thing.
it can be because of weeping. If weeping is there, then the liquid holder will be low, and then this will be
That is process parameter, but HAZOP
yeah.
doesn't have to do with the process parameter. High pressure has gone in the column. You have to suggest something.
Yeah, if the high pressure is there, then there must be I think field is very
You have heard
field is
about
high, so I
PSVs,
think we should grow the
pressure safety valve.
PSVs, yeah, pressure safety valve.
So
Yeah,
what you HAZOP is like that only. ठीक है?
yeah, PSV has been choked or something. We
हाँ,
should see.
you have to install a PSV there. ठीक है?
We have to install PSV there.
कॉलम में PSV नहीं है तो PSV इंस्टॉल करना है, ठीक है. तो HAZOP आप जब बोल रहे हैं, ठीक है, सो 4 पॉइंट्स यू आइडेंटिफाई, ठीक है. फर्स्ट इज यू सिलेक्ट द नोड, ठीक है. सेकंड इज द यू सिलेक्ट द कंडीशंस, मोर फ्लो, लेस फ्लो, मोर टेम्परेचर, लेस टेम्परेचर, मोर प्रेशर, लो प्रेशर, ठीक है. अब ये आ गया, देन यू लिस्ट डाउन द कंडीशंस, at what conditions more pressure will go, more temperature will go, more flow will go. Then the recommendations. In that recommendations, you have, this is the complete HAZOP. Okay? So when you are saying HAZOP, so you should break it down in that level. Okay? In HERA
Yes.
also, you should break
Yes,
it down in that level. Okay? So if emphasizing on the HAZOP, that's why I have asked about the HAZOP. Basically, if you not say HAZOP, at this empty level, no one will ask about you about the HAZOP. So it will be beneficial for you also. You know about HAZOP, but you just break it down at some levels. Okay. ठीक है. So any other subjects you like?
the heat transfer,
Heat transfer and
yeah, fluid mechanics, pump, and so mass transfer.
mass transfer. Okay. Mass transfer. Suppose there is a distillation column. ठीक है. And very close boiling point liquids you have to separate it out. Okay. What are the methods by which you can do that?
So for separating close boiling point liquids, we will use a vacuum distillation unit first of all.
So
Because,
what it
as-
does means
yeah.
मतलब ऐसा कैसे होता है कि if you reduce the pressure, ठीक है, how the relative volatility increases?
Yes, sir. So as we okay, so first of all, we'll define relative volatility. Okay, relative volatility is the vapor pressure of more volatile component and vapor pressure of less volatile component. Ratio of these two. So
Okay.
now as we increase the pressure, the more vapors will form. Now PAV, the more volatile component is already forming more vapors. But as we increase the pressure, PAV, vapor non-volatile component will also form more vapors. So so this will cause our relative volatility to increase because PAV will decrease.
Relative volatility is the ratio of vapor pressures. Correct?
Yes, sir. It's also
Okay.
it can be defined
And
another ways, but
vapor pressure is the function of
temperature.
temperature. ठीक है? So as you reduce the temperature, as you reduce the pressure, the deviation in the vapor pressure of the both the fluids will not be the same. ठीक है?
Yes, sir.
So you would say like that कि
But
अगर एक ATM at 1 bar pressure, if boiling point of one liquid is 100 degrees Celsius and another liquid is 101 degrees Celsius, so it will not be like that कि when the pressure is 0.6 bar, then the boiling point it will be 90 and 91. The boiling point will differ by 90 and 96. ठीक है? So relative volatility increases because the variation in vapor pressure is different for different fluids. ठीक है? So
yes, sir.
you have to link it with the temperature and say कि boiling point of the is pressure dependent और सबका individually vary होता है. ठीक है? So as you reduce the pressure, the difference between the vapor pressure increases, leading to increase in the relative volatility and hence the ease of separation. Okay.
Yes,
Do you know about that Nusselt number?
yes, sir.
What is Nusselt number?
So basically, Nusselt number talks about heat transfer due to convection flux divided by heat transfer due to conduction flux. Basically,
Okay.
it talks about yeah, how
So
much
how is it?
heat,
uh,
how much heat transfer
How
flux
is
will be increased if advection is present by if it's not present.
okay? How it is related with Reynolds number?
Nusselt number is basically Nusselt number basically can be said product of Reynolds number and Prandtl number.
But how it is related to Reynolds number? Whether is there any empirical formula you know? Ki Nusselt
Yeah,
number is related to this Reynolds number.
we
If you
can.
want to
I
calculate
can.
Nusselt number and
There's
you know Reynolds number,
yeah. We can use Dittus-Butler equation, which is Nusselt number equal to 0.023 Reynolds number raised to the power 0.8 and Prandtl number raised to the power 1 by n. 1 by 3, you can say 0.3 and 0.4, 0.3 for cooling of fluid and 0.4 for heating of fluid. And you can also, I
okay.
think, yeah.
Now, can you tell me about the difference between that wet bulb temperature and dew point?
Yeah, so dew point temperature is the temperature that is actually measured by the thermometer, whereas wet bulb temperature is basically the temperature when a thermometer bulb is covered with muslin cloth and it's left to get saturated with the environment. Then what happens? The evaporative cooling occurs there, and then the temperature measured by the thermometer is wet bulb temperature.
Which is lower? Wet bulb temperature is lower or this dew point is lower?
Sir, wet bulb temperature is lower than dew point temperature until it's saturated.
Wet bulb temperature is lower than dew point temperature.
Yes, sir.
चेक करिए आप एक बार इसको.
Sure, sir.
At 100% saturation, what will happen?
So both will be equal.
Both will be equal. Otherwise, wet bulb temperature will always be higher than that of dew point.
I think.
ठीक
Okay.
है? इसको चेक करिए. And do you know about this bound moisture and unbound moisture in dryers?
Yes, sir. So
Hmm.
bound moisture
Can
is the moisture that is present on the surface of surface of the solid. So unbound moisture is the moisture that is trapped between the solid. So basically, it is in case of drying, the bound moisture can be removed by at a constant rate, but to remove the unbound moisture, the rate decreases. And also, you can say that the unbound moisture exert vapor pressure, whereas bound moisture exert pressure that is less than vapor pressure.
okay. ठीक है. Anything you want to ask?
So I think a lot of time I know the answer, but the words fumble during interview. Like
नहीं फंबल नहीं आपका आपको अच्छा बताया आपने. ठीक है. एक आध दो चीज इधर उधर चलती है, कोई दिक्कत नहीं है. ठीक है. आपने जो हेजॉप और हीरा जो सिलेक्ट किया ना सब्जेक्ट शुरू में बोला, दैट इज वेरी ह्यूज सब्जेक्ट, ठीक है। और स्पेशली इन इंडस्ट्रीज ना, व्हेन वी सजेस्ट एनी मॉडिफिकेशन और डू डिजाइन इंजीनियरिंग, ठीक है, हेजॉप इज अ ह्यूज वर्ड, सो इट विल ओपन ऑल द ईयर्स, ठीक है। तो इफ यू आर सेइंग हेजॉप, इट विल बी बेनिफिशियल फॉर यू, बट थोड़ा सा उसको बेसिक वे में, उसको बेसिक क्या है उसका, बस they'll expect that from you, but that will be benefit for you, ठीक है। सो आपका इंट्रो सही है, ठीक है, हेजॉप बोल देना, बट हेजॉप को ब्रेक डाउन करो, जैसे मैंने 5 चीजों में ब्रेक डाउन किया ना, यू ब्रेक डाउन इन दैट सेंस ओनली, ठीक है।
सो मैटर ऑफ फैक्ट मैंने आज ही सुबह मैंने सारा पढ़ा था, फिर वही कि इसका मैं थोड़ा नर्वस हो जाता हूँ, मतलब मैटर ऑफ फैक्ट मैं हेजअप का फुल फॉर्म भूल गया, क्योंकि मैं वो तो सब पढ़ाई था ऑब्वियसली, सुबह ही देखा था सब कुछ,
ठीक है, तो
सर वो तो
दैट इज द बेसिक थिंग ना, समवन विल आस्क यू कि हेजॉप बोला तो हेजॉप का फुल फॉर्म क्या है, ठीक है।
हाँ
सो
तो
बेसिक सेंस
मतलब
आ
देखा
जाता
ही
है।
होगा ऑब्वियसली,
नहीं,
हाँ तो
ओके,
मतलब
ठीक है, वो क्या है, 2-4 बार आप दोगे ना इंटरव्यू, यू विल गेट टू नो थिंग्स, ठीक है। तो वैसा सबको सब कुछ नहीं मालूम है, ठीक है, एंड इट इज ऑलवेज टफर बी ऑन योर साइड, ठीक है। तो आपका तैयारी अच्छा है, ठीक है, बस आप जो बोल रहे हो ना, ठीक है, क्योंकि आपका जो इंट्रोडक्शन है 2 मिनट का, अच्छा इंट्रोडक्शन है, आपने कई सारी चीज बता दी, ठीक है। सर्टिफिकेशन भी आपका दैट विल क्रिएट अ गुड इंप्रेशन, ठीक है, आपने जो बताया उसको वैसे ही रखना है, ठीक है। अपने इंट्रोडक्शन को बेसिकली क्या है, हम लोग अपने टाइम पे क्या करते थे कि माय इंट्रोडक्शन ना, यू राइट इट डाउन, ठीक है, 8 और 10 लाइंस, यू राइट इट डाउन एंड यू राइट इट डाउन डेली, ठीक है। सो वो क्या है, आपके अंदर चला जाता है, ठीक है। जब आपके अंदर चला जाएगा तो आपको अंदर से क्वेश्चन आ जाएगा कि यार ये बोल रहा हूँ तो इसके लिए क्या पूछ सकते हैं। सो इट विल बी, पर सबको रिकमेंड करूंगा कि दे जस्ट राइट डाउन देयर इंट्रोडक्शंस डेली, यू राइट, मतलब कि हार्डली 7 to 8 days आर लेफ्ट, ठीक है। तो व्हेन यू राइट इट डाउन ना, आप खुद ही पता चलेगा यार ये नहीं बोलना चाहिए, यार ये गलत बोल दिया, या ये नहीं बोलना चाहिए, ठीक है। सो इट विल ऑलवेज बी बेटर, ठीक है। और बाकी तैयारी अच्छा है आपका, अच्छा किया आपने, ठीक है।
एनीथिंग एल्स आई शुड
होमवर्क करने की
इम्प्रूव?
कोई जरूरत नहीं है, आराम से देने का है, ठीक है।
जी सर।
प्रैक्टिस करते रहना है, इंट्रोडक्शन पे ध्यान देना है, और जो भी बोल रहे हैं आप इंट्रोडक्शन में, दैट विल क्रिएट द इंप्रेशन,
क्वेश्चंस,
ठीक
ओके
है।
ओके सर, थैंक यू सो मच।
Recording stopped.
हाँ,
Recording in progress.
Good evening, sir. My name is Sandeep Singh Rawat, and I am from Ajmer, Rajasthan. I have completed my BTech in Chemical Engineering from NIT Bhopal. In my family, my father is shopkeeper, my mother is homemaker, and my elder sister is working in Indian Railways for Group D as a track maintenance. And I have worked for Ultratech Cement for 2 years, and I have recently resigned from there on in July 2025 for focusing to to the opportunities which are more aligned with my long-term career goals. And apart from it, my hobbies are to play cricket and watch sports.
okay, ठीक है। So in cement plant you have worked, huh?
Yes, sir.
In which department?
Yes, sir, I have worked in process or I would say production department.
Okay. So whether your plant was producing cement only or clinker plus cement?
Sir, it was producing clinker plus cement.
Clinker plus cement.
Yes.
Okay. What was the production capacity?
The production capacity was 3.3 million ton per annum of cement.
Okay. There's a special kiln is used in this these type of cement plants. What is the name of that kiln?
The rotary kiln it is used.
Okay, I don't know the name, but there's a something special that kiln name is there.
Sir, it is rotary kiln.
You just Google the name, okay? And you were in the DCS or you were in the field?
Sir, actually, my plant was I was part of project commissioning it was commissioned in approximately 1 year, and I have been part around 11 months in process where I've looked upon the material management and like MIS report and material procurement, and in SAP I have also about and PP module of SAP. So I have more or less seen the administrative work, and I have not been much part of the operation. I wanted to be part of that, but unfortunately I didn't get
No, it's
that
okay.
much of opportunities.
You work on the management part, no? That is okay. Okay.
Yes.
So, what are your any favorite subjects you have?
The favorite subjects I have thermodynamics and heat transfer.
Okay. Can you tell me that what is the difference between the first law of thermodynamics and second law of thermodynamics? Just the difference.
The first law of thermodynamics states about the whatever energy given to system, then where that energy used, like it it is either used in change in its internal energy or to the work done by the system, or I would say it is the law of conservation of the energy. And in second law of thermodynamics, it states that it is given for heat engine and refrigerator, where and many applications that it is there are two statements for it. One is Kelvin Planck statement, which suggests that it is impossible to make an engine which can be 100% convert the heat into work, and the second statement of classes which suggests that it is impossible to send the heat from lower temperature to higher temperature without doing any work.
Hmm. So, do you know any practical example of this Clausius statement? Anything which is in your house, which is
Yes,
doing the
right.
same thing?
The refrigerator.
Refrigerator, how it is doing?
The refrigerator is we are giving it we are doing work as we are giving electrical energy to it.
Electrical energy means how it is working means how a refrigeration cycle works.
Actually, I have not aware about it. I have
हाँ.
not read about
तो
it.
बेसिकली क्या है कि दैट द वर्क यू आर सेइंग ना दैट इज कंप्रेसर ओनली. ठीक है.
Okay.
तो अपने रेफ्रिजरेटर में कंप्रेसर होता है, तो आप अगर थर्मोडायनेमिक्स बोल रहे हैं तो बेसिक थिंग इज रेफ्रिजरेशन साइकिल. ठीक है.
Definitely.
सो यू शुड नो अबाउट दिस रेफ्रिजरेशन साइकिल. ठीक है.
Okay.
रेफ्रिजरेशन साइकिल अच्छे से पढ़ना है आपको. ठीक है. और आपने क्या बोला है? हीट ट्रांसफर बोला है शायद. है
Yes.
हीट ट्रांसफर बोला है. ठीक है. तो हाउ द वॉल थिकनेस, ठीक है, अफेक्ट्स द हीट ट्रांसफर. ठीक है.
Yes.
मीन्स
Sir.
सपोज a 1 mm pipe is there. ठीक है. आई एम
Yes.
टॉकिंग अबाउट a whole heat transfer. Suppose a
Okay.
pipe having ID of 1 mm, ठीक है, a thickness
Okay.
of 2 mm, ठीक है, and a fluid is passing by for cooling. ठीक है. If I reduce the ID to 0.8 mm and increase the 3 mm size thickness to 3 mm, ठीक है,
Okay.
whether heat transfer will improve or not improve?
Sir, it depends. It can increase or decrease because because rate of rate of cooling is in cylindrical vessel. We can give as delta T upon ln R2 upon R1 by 2 pi KL, where
Can you tell me about with respect to conduction and convection? What will increase,
okay,
what will reduce?
okay. So we have basically reduced the inner diameter from 1 mm to 0.8 mm.
We have reduced the internal diameter.
Okay, 1 mm to 0.8 mm.
हाँ.
So inner convective resistance will be decreasing.
Hmm.
So the convective heat transfer will increase, and
Hmm.
for conduction For conduction, R2 by R1 ratio is increasing, so there would be decrease in heat transfer by conduction. Yes, sir.
ओके गुड ठीक है अभी बताओ कि व्हाट आर द डिफरेंट टाइप्स ऑफ हीट एक्सचेंजर्स यू नो मतलब what type of heat exchangers are beneficial means whether it is parallel flow are beneficial or counter current beneficial is there any statement can be given like that कि always counter current heat exchangers are better than that of parallel flow heat exchangers
No, sir. I think counter flow are generally used and are highly efficient than parallel flow heat exchanger. But for some cases, there are some cases for which both are equally efficient. Like
so can you tell me any one case where that parallel flow can be used instead of counter current
for condenser,
कंडेंसर में क्या होता है
the condenser में the जो वेपर होती है वो वेपर vapor condenses and it gives energy to cold fluid. So it takes energy from the condensing vapor
इसको आप
and
ऐसे
it
बोलना कि वेयर एवर ठीक है वेयर एवर वन फ्लूइड टेम्परेचर इज कांस्टेंट ठीक है मतलब वेदर मतलब बोलना कि वेदर देयर इज व्हेन एवर देयर इज अ फेज चेंज इन वन फ्लूइड ठीक है देन वी कैन यूज द पैरेलल फ्लो ठीक है वेदर वेयर एवर ठीक है
evaporator हो condense.
ठीक है और अदर टाइप ऑफ काउंटर करंट हो क्रॉस करंट भी होता है वेदर वी कैन यूज क्रॉस करंट आल्सो
Uh, Actually, I have told you about heat transfer, but yes, I was being confident in heat transfer, but I have not deeply studied about technical things
ओके
more. Yes.
ठीक है जस्ट लर्न अबाउट दैट हीट ट्रांसफर ठीक है एक होता है कैन यू प्रैक्टिकली एक्सप्लेन मी अबाउट टू टाइप्स ऑफ कन्वेक्शंस आर देयर कैन यू नेम इट
Yes, sir. It is natural convection and forced convection.
फोर्स कन्वेक्शन है नेचुरल कन्वेक्शन तो
Yes.
अभी आप जहाँ रह रहे हैं वहाँ ठंड आ गई होगी
Yes, yes.
ठंड आ गई तो आपके घर के आगे बाइक खड़ी होगी तो उस पे ड्यू बैठ जाता है
Yes, yes.
क्यों बैठ जाता है वो
The dew is just because of the evaporation phenomena.
इवेपोरेशन वेदर इट इज इवेपोरेशन
The water vapor in air gets condensed on the it gives it gives its energy to sir. Actually, I'm not getting it.
सरफेस हमारा सरफेस ठंडा हो गया ना सरफेस ठंडा हो गया तो क्या होगा वाटर पेपर क्या है कंडेंस होना चालू हो जाएंगे सरफेस पे बैठना चालू हो जाएंगे
Yes.
ह्यूमिडिटी बेसिकली ह्यूमिडिटी डाउन हो जाएगी एयर की ह्यूमिडिटी जैसे डाउन होगी तो वेपर वहां पे बैठना चालू हो जाएगा ठीक है सो दैट इज
Yes.
अबाउट कंडेंसेशन ठीक है आपको कुछ पूछना है
सर मेरे को ये पूछना था जैसे कि मैंने अभी थोड़ा एचआर वगैरह प्रिपेयर किया है एंड टेक्निकल मेरे को मतलब ओवरव्यू आता है मैंने काफी पढ़ा भी है बट स्टिल आई नीड टू इम्प्रूव.
ठीक है एक चीज थोड़ा आप ये देखना इंट्रोडक्शन ठीक है आपका बट ये डोंट एम्फेसाइज ऑन दिस थिंग कि आई हैव लेफ्ट द जॉब एंड आई वांट टू प्रिपेयर ठीक है मतलब ये इस पे एम्फेसाइज मत करो ठीक है आई हैव वर्क देयर बट सिंपल एक लाइन कि नाउ आई एम प्रिपेयरिंग फॉर दिस गवर्नमेंट एग्जाम्स ठीक है
ओके
ठीक है तो वो एक फैक्टर आप हटा दो अपने इंट्रोडक्शन से हटा ही दो उसको ठीक है ठीक है क्योंकि फर्स्ट क्या है आपने टेक्निकल में उधर काम किया नहीं है ठीक है सो आप शुरू में क्लैरिफाई थोड़ा अगर पूछें एक दो क्वेश्चंस तो बता के क्लैरिफाई कर देना जैसे मेरे को किया वैसे उनको भी कर देना और दूसरा ये वाला पार्ट आप हटा देना कि आई वाज जो भी आप बोल रहे थे वो हटा के सिंपल बोल देना नाउ आई एम प्रिपेयरिंग फॉर द गवर्नमेंट जॉब मैंने रिजाइन कर दिया ये कर दिया वो के अनइवन क्वेश्चंस लाता है क्यों रिजाइन कर दिया फिर तुम बोलोगे काम पसंद नहीं आ रहा है ये बोले काम पसंद नहीं आ रहा है तो तुमको यहाँ पसंद नहीं आएगा, तुम यहाँ भी छोड़ दोगे, तो इसलिए वो सब क्वेश्चंस आते हैं, तो वो छोड़ देना, ठीक है। दूसरा एक क्या है, टेक्निकल में ध्यान देने की जरूरत है, ठीक है। अगर आप कोई भी चीज बोल रहे हैं, आपने थर्मोडायनेमिक्स बोला, तो दीज आर द बेसिक थिंग। फर्स्ट लॉ ऑफ थर्मोडायनेमिक्स क्या है, सेकंड लॉ ऑफ थर्मोडायनेमिक्स क्या है, सेकंड लॉ में आपके घर में आसपास क्या यूज हो रहा है, रेफ्रिजरेशन यूज हो रहा है, रेफ्रिजरेशन साइकिल क्या है, ठीक है। तो ये हीट ट्रांसफर, अगर आप कोई भी दो चीज बोलना तो शुड बी श्योर अबाउट इट, इज द बेसिक पार्ट। आपने अच्छी बात ये, आपने जो हीट एक्सचेंजर वाला है क्वेश्चन, ठीक है, उसका आपने अच्छा आंसर दिया, ठीक है। एनीवन विल अप्रिशिएट दैट, ठीक है। और आपने सोच के आंसर दिया है, बड़ी अच्छी बात है, ठीक है। तो यही वाली जो सोच है आपको आगे बढ़ानी है, ठीक है। तो थोड़ा सा जल्दी जल्दी काम करने की जरूरत है, तो 4-5 दिन आप थोड़ा टेक्निकल पे ध्यान दीजिए, है ना। और एक मास ट्रांसफर को भी थोड़ा इंक्लूड कर लीजिए। थर्मोडायनेमिक्स हीट ट्रांसफर में एक बोलेंगे तो चलेगा, मास ट्रांसफर को थोड़ा इंक्लूड कर लीजिए, ठीक है। ओके,
Thank you.
ठीक है। एक मिनट यार, हाँ।
Recording stopped.
हाँ, आ जाओ यार।
Good evening.
हाँ
Recording in progress.
Sir, introduction start.
हाँ, थोड़ा सा तेज बोलना बस।
Okay, sir. Good evening, sir. My name is Mayur Kakade. I was born in Gujarat, uh, uh, brought up in Mumbai, and my hometown is Junnar, which is also known for its historic Shivneri temple. I have completed my BTech from MGM College of Engineering and Technology from in Navi Mumbai. I have recently completed my MTech in Chemical Engineering from IIT Kharagpur. My MTech project focused on energy efficient transportation of high viscous oil through horizontal pipeline using core annular flow. Along with this, I have had industrial exposure through a couple of internships, one out of which was at Paradip Phosphate Limited, where I was assigned the project of comprehensive water balance of entire plant, along with efficiency analysis of effluent treatment plant and surface runoff calculations. Apart from this, apart from the academic pursuits, I have also undertaken few leadership roles. I served as the PG representative for sports and games in IIT Kharagpur Gymkhana. Apart from this, I like to sing and I like to play cricket. Thank you, sir. That's all about.
Okay, good. You said about that you have worked in that decreasing. You're doing the energy conservation by while pumping that viscous oil to the industry in horizontal pipeline. So, what oil was you using?
Yes, sir. That was my MTech project, and
What
the
was
oil that was used was lubricating oil, having a viscosity of 0.3 Pascal seconds.
Pascal seconds. Basically, how you are doing that?
Sir, so we know that for a very high viscous oil, the pumping power that is required is more, and that is a challenge that the industries are facing. For that, one method that we used was core annular flow. Now, core annular flow is a multi-phase flow phenomena where the two fluids, in our case water and oil, flow in such a way that the more viscous fluid flow through the core region and the in a pipeline, and the less viscous, that is water, flow in the annular region, which means there is no direct contact between the oil and the surface of the pipe, and that's why it kind of creates a lubrication for the oil, and this reduces the pressure drop significantly.
Okay. Now, when you're pumping oil with the water, okay,
Yes.
so that oil, water must be mixing with the oil. Okay.
Yes, yes, sir.
So how you are separating that then?
Sir, towards the downstream or in the pipe?
Towards the downstream. Towards the downstream, you have transported the oil, but
Yes,
now
sir.
the water and oil are slightly mixed. Na? That oil has become
Yes,
some milky only.
Mhm.
So how you are then separating that oil and water?
Sir, we are collecting it in a drum and then giving it enough time to separate.
And it will separate.
Gravity. Gravity separation. Yes, sir. Because because of density difference.
ठीक है,
The
मतलब
density difference between the oil and water is high. So
it is high only. That is correct only. But basic thing is that whenever you are using a lubricating oil, ठीक है,
yes, sir.
we also check its moisture content also. ठीक है,
Okay, sir.
ठीक है, and if the moisture content in the oil is high, ठीक है, that also leads to wear here of the moving parts. ठीक है, so that's why I am asking about this separation. So if you are sure about it कि they are doing by gravity only and they are not having problem with the oil, then that is okay. And if you are just making the answer, you don't know, just know it कि
Sir,
how
this
they are
was my lab scale experiment. It was not in any industry. It was my project.
because industrial, the main thing will arrive in that only कि how you have reduced the pumping power, that is good only, but how you separate water and oil? It is not like that कि by density difference you cannot completely separate oil and water. Also, there will be a loss of oil also because that intermediate layer you can't separate even at a residence time of 24 hours or 48 hours. Okay? So there will be loss of oil also. Okay? So you just check on it. Okay?
Yes, sir.
It
We
is
have
not on industrial scale, so okay. But I thought it is an industrial scale, so it may not be.
And sir, we have also tried to tackle this problem also because we know that even after gravity separation, there is some impurities in water. So we have reduced the water cut to a mere 4%. So in the optimum results which we have got, only 4% of water was required
Correct.
for this
Then then it is okay. Now tell me the basic principle. Why the that boundary wall, that water is preferred? Okay? What is the reason? Because of the what is the basic phenomena क्या है? Why the pressure drop was more? Because of the viscosity.
Okay, sir. Sir, because of the viscosity itself means resistance to flow. So when a high viscous fluid is pumped, okay, it is pumped, so there is more resistance to pump a high viscous fluid rather than
how this viscous is correct. I'm just elaborating it. Whether it is related to boundary layer, layer thickness,
Yes, sir. Yes, sir.
So for a high viscous fluid, whether this boundary layer thickness will be high or whether boundary thickness will be low.
Sir, the boundary layer thickness for high viscous fluid will be high because the pipe wall is stationary, and as the fluid is moving and as it is high viscous, so the layers of the layers of the oil will resist each other, or they will try to intact each other. They won't allow them to flow. That's why the pressure drop to pump that also increases.
Okay, good. So basically वो आपने सही बताया, ठीक है, उसको वही बताना है, बाउंड्री लेयर के टर्म्स में बता देना, बाउंड्री लेयर थिकनेस ऑफ दिस वाटर will be less, so that the maximum velocity can be achieved at the center of the pipe. Otherwise the boundary layer thickness will be that much that the velocity cannot be achieved only. ठीक है, तो अच्छा बताया आपने, ठीक है, गुड, अच्छा काम है, ठीक है. And any other subjects you like?
Yes, sir. I like mass transfer operation, heat transfer operation, fluid mechanics.
Fluid mechanics. So can you tell me any pressure, मतलब suppose a flow is going through a pipe, ठीक है, what will happen if I increase the dia of the pipe? What will happen to the DP, delta differential pressure?
Pressure,
Pressure.
DP, yeah.
Differential pressure. Yes, DP.
So the differential pressure depends on the diameter based on the type of flow. So if the flow is laminar, according to Hagen-Poiseuille equation, it is inversely proportional to the square of diameter. The pressure drop is inversely proportional to the square of diameter. So if the diameter is increased, the pressure drop will reduce. And in case of turbulent, if we consider the friction factor to be constant, then too it is inversely proportional, I think, to diameter, not the square but diameter. So in that case, also it will, if diameter is increased, the
that is
pressure drop will decrease.
Darcy's equation, 4FLV square by 2GD.
Yes, sir.
That D will be the inversely proportional. Okay.
Correct, sir. Correct.
Good. Do you know about that numbers? Nusselt number, Reynolds number, Schmidt number?
Yes, sir. Yes, sir. I know.
So what is the significance of these numbers? What do they tell us?
There are different significance for different numbers. For example, if we consider Prandtl number, Prandtl number is the ratio of momentum diffusivity to thermal diffusivity. So it can be used to measure which diffusivity is more, or which is more prevalent, or we can also say which boundary layer thickness is more using Prandtl number. Similarly, for mass diffusivity, we can use concentration boundary layer, we can use Schmidt number. And when we talk about Nusselt number, Nusselt is the ratio of convection heat transfer, or heat transfer due to convection to the heat transfer due to conduction. So Nusselt number shows us how much the heat transfer is being affected due to the bulk motion transfer, because there is convection, right? So if there was no convection, the Nusselt number would have been 1. But as there is convection, as there is bulk motion in the fluid, then the Nusselt number is increasing. So it quantifies that value, that how much it is being affected.
Okay, good. अच्छा है, आपका तैयारी भी अच्छा है, और आपका बताने का, तो आपको कुछ पूछना है पहले, आप बता दो।
सर आप ही बता दो, मतलब क्या और इम्प्रूव कर सकता हूँ मैं?
नहीं,
मुझे लगता है कि मैं बहुत ज्यादा करता हूँ जब
नहीं, मैटर नहीं करता ये। आप क्या है, as long as you are giving right answer ना, it doesn't matter कि क्या बोल रहे हो। बाकी आपके करेक्ट आंसर्स करेक्ट थे, ठीक है। दूसरा, ये आपका प्रोजेक्ट है, आपने उसको थ्योरेटिकली भी पढ़ा है, ठीक है, अच्छी बात है, ठीक है। सो इट विल बेनिफिट यू ओनली, ठीक है। सब अच्छा है, मतलब ठीक है, ऐसा मतलब कुछ मुझे लगा नहीं कि नहीं हो सकता, पर फिर भी अपने को ओवर कॉन्फिडेंट नहीं होना है, रोज थोड़ा पढ़ते जाना है, इंट्रोडक्शन रोज लिख लेना है, ठीक है। और एनी बिकॉज क्या है ना कि अगर आप नियरली परफेक्ट इंटरव्यू देते हो ना, तो इधर उधर से, जैसे मैंने पूछा नहीं शायद से कि व्हाट यू नो अबाउट दिस ऑर्गेनाइजेशन, सो यू हैव रेड अबाउट इट और नॉट?
यस सर, आई हैव रेड इट।
हाँ, बता दो थोड़ा क्या है।
सो इंडियन ऑयल Corporation Limited is a leading company in petroleum and oil and gas sector. It has 10 refineries in India. Talking about the chairman of IOCL, it is Mr. A.S. Sahane. Also, now IOCL is investing into petrochemical and newer fuels as well, that is green hydrogen and all. Yes sir.
गुड, ठीक है, मतलब सब बढ़िया है, बस डेली प्रैक्टिस करते रहना है, ठीक है। लास्ट दिन डिलीवर करना है अपने को, यही रखना है बस।
Yes sir, yes. Sure sir, sure.
गुड,
Thank you.
Recording stopped.
यस।
Hello sir, am I audible?
थोड़ा सा तेज बोलिए।
So may I introduce?
हाँ, ठीक है, बताइए।
Good evening sir, Thank you for giving me this opportunity to introduce myself. My name is Anisha Satpathy. I'm born and brought up in Haldia. I have done my BTech degree from Haldia Institute of Technology in Chemical Engineering. Currently, I'm pursuing my MTech degree from Jadavpur University, which I have joined this year. My final year project was on the topic of development of polymeric hydrogels from sodium algylate and polyvinyl alcohol and extraction of amoxicillin using those polymeric hydrogels. My favorite subjects are heat transfer operation, fluid mechanics, chemical reaction engineering, and mass transfer operation. And my hobbies include I love to sing, I'm into dancing and different fitness activities, and gardening. That's about me, sir.
Okay, good. You have said about this chemical reaction engineering.
Yes, sir.
Okay. Do you know what is the order of a reaction? What does it tells you?
Yes, sir. Order of reaction, we can define it for elementary reaction as well as for the non-elementary reaction. And for elementary reaction, the order of reaction is the summation of the coefficient and equal to the molecularity of the reaction. Whereas for non-elementary reaction, it can be greater than 3 or greater than the molecularity of the reactants that is participating in the reaction.
Okay.
So it is a practical approach that we take experimentally determined data.
What are the different types of reactors, you know?
So there are different types of reactors like batch reactor, there is CSTR and PFR that we commonly used.
Any more reactors, you know?
So there is packed bed reactor and fluidized bed reactor as well.
Semi-batch reactor, you know?
Yes, a semi-batch reactor.
So in what applications we can use semi-batch reactor?
So in different pharmaceutical industries, I guess we use semi-batch reactors where although there is continuous flow, uh, but the product is taken out by a batch operation, or the inlet can be also a batch operation and the outlet can be a continuous flow.
Okay. What is the basic difference between a CSTR and a PFR? Means how you select if you want to have a CSTR reactor or you want to have a PFR reactor.
So first, it is dependent on the order of the reaction. For positive order reaction, we generally go for PFRs because the concentration is not rapidly dropping in PFR. But in CSTR, there is stirring process. Because of that, the concentration is dropping rapidly. So for negative order reaction, we prefer CSTR more.
So whether any series of these reactors can be converted into another?
Sorry, sir.
Whether a series of means suppose you have 3 CSTRs, okay, and you have 1 PFR, okay, volume of the reactors are same, okay. Suppose you have 1 meter cube each 3 reactors CSTR, and you have 3 meter cube PFR, okay, and order of reaction is one or zero, in which that volume is same. I think zero only.
Yes, sir.
Yes. So which reactor you will use? Either CSTR or PFR?
So for three series of CSTR, we can consider it as a PFR because the volume is equivalent to the PFR. And when there is series of PFRs involved, we can consider it as a single PFR.
Okay.
And the conversation we will get at the outlet will be same.
So there are some reactions also in which some products are not required. Some byproducts are made which are
Yes.
not required. Okay. So how you select these type of reactors means how you can select these reactors in which something, suppose if A is the component, S is the product, and R is the byproduct. Okay. But there is a time delay between production of S and R. R जल्दी बन जाता है and S जो है delay में बनता है. So how you choose the reactor?
So we can see the selectivity, which is the ratio between the desired product that is formed to the undesired product, and we can vary the temperature accordingly. So if the specific rate constant is higher, we can keep the temperature higher and get the desired product. And if the temperature is lower for the undesired product, we can set it like that.
Okay. Now tell me whether this solubility, gas solubility in
Yes.
liquids. So whether
Yes.
it increases with temperature or decreases with temperature.
So if we decrease the temperature, the gas solubility will increase in a liquid.
Means if temperature is decreased, solubility is decreased.
Decreasing.
Decreased.
Yes.
Okay. So you have क्या बोलते हैं, you must have drunk cold drink. You have must drunk cold drink, no? Cold drink
Yes.
पिया आपने? हाँ.
Yes.
तो उसमें water जब seal रहता है, then CO2 is dissolved in that.
Yes, sir.
और जब आप उसको रिलीज करते हैं तो CO2 निकल जाता है उसमें से. क्यों होता है ऐसा?
So because it is under high pressure, that is because of the reason the CO2 is remaining soluble in water, and as soon as we are removing the high pressure, it is basically escaping from the water.
Okay. Why CO2 is added? Do you know? Why CO2 is added only? Why not another air?
Sir, I think it is because it is easily soluble uh, in water. So,
Polygon code that which is ठीक है. Anything you want to ask?
so overall, where can I improve in my
क्या
interview?
चीज?
Where can I improve in my interview?
नहीं, अच्छा है आपका. वोकेबलरी भी अच्छा है. ठीक है. मैंने तो आपको रिएक्शन इंजीनियरिंग में ही पूछा. रिएक्शन इंजीनियरिंग में अच्छा बताया आपने. इंट्रोडक्शन भी अच्छा है आपका. ठीक है. ऐसा कोई इशू तो मुझे लगा नहीं. बाकी सब्जेक्ट्स में शायद टच अपॉन नहीं कर पाया. ठीक है. बिकॉज मैं सबसे शायद हीट ट्रांसफर मास ट्रांसफर पूछ रहा था, तो इसलिए आपसे रिएक्शन इंजीनियरिंग पूछ लिया. आपने रिएक्शन इंजीनियरिंग बोला भी, तो रिएक्शन इंजीनियरिंग आपका अच्छा है. ठीक है. हीट ट्रांसफर मास ट्रांसफर भी मैंने हीट ट्रांसफर थोड़ा टच किया, तो ओके है. अच्छा लग रहा है. ठीक है. इंट्रोडक्शन भी अच्छा है आपका. तो प्रेजेंटेशन अच्छा था आपका. ऐसा कोई इशू मुझे तो नहीं लगा है. ठीक है. बाकी स्टिल अगर कोई और इंटरव्यू लेगा तो शायद उसको कुछ लगे. मुझे तो अच्छा लगा है.
Thank you, sir.
ओके. और कोई है? एनीवन देयर? हो गया?
Hello.
हेलो.
Sir, can I give my interview?
हाँ, एक मिनट यार, ये स्क्रीन शेयर कर लूँ मैं वापस से.
Okay, sir. Okay.
कहाँ से तो गए हैं? हाँ, चलो मैं दिखाई दे रहा हूँ.
Yes, sir.
Recording in progress.
Can I introduce myself, sir?
Yes, please.
Sir, my name is Sayak Ghosh. I currently reside in Kolkata. I have completed my BTech in Indian Institute of Petroleum and Energy, Visakhapatnam, in Chemical Engineering. I have done my summer internship in IOCL Gujarat Refinery, Vadodara, in hydrogen generation unit. And sir, I have done my project in control of 3-tank system, BTech final year project. My hobbies include clicking photographs and interacting with people to understand their psychology and to understand the world order, like from their point of view, how they see the world.
Okay, ठीक है. आपने प्रोजेक्ट क्या बताया अपना?
Sir, control of 3-tank process.
3-tank process.
Yes, sir.
क्या होता है ये थोड़ा
Instrumentation.
बताएंगे?
Yes, sir. Sir, basically, as we know that first order system, when we connect 3 first order system in series, it becomes third order. And how the time constant is varying, like it is basically an overdamped system, and how the time constant is varying. Time constant is varying the variation, because if we know, sir, that if the time constant is large, the process becomes sluggish, and if the time constant decreases, sir, it becomes fast. And we for different data points we took, we saw that the time it becomes more sluggish, because as the order increases, sir, it becomes sluggish. Like this was our experiment to show that the response of the system, speed of the response decreases as time progresses, because the order increases, sir.
Okay.
Yes, sir.
अभी what are your favorite subjects?
Sir, my favorite subjects include mass transfer and heat transfer.
Okay, mass transfer and heat transfer. So,
Yes, sir.
what is the basic formula for radiation?
Sir, radiation is basic formula is that sigma T to the power of 4, Stephen Boltzmann law.
What is the Stephen Boltzmann law? Or what is sigma? What is the value of sigma?
Yes, sir. The value of sigma is 5.67 into 10 to the power minus 8 watt per Kelvin to the power 4.
Okay. Any unit up इतना ही है क्या उसका?
Yes, sir.
What is the unit?
Yes, sir. Watt per Kelvin to the watt per meter square Kelvin to the power 4.
Watt per meter square. ठीक है.
Yes, sir.
What is the unit of conductivity?
The unit of conductivity is watt per meter Kelvin.
And for the heat transfer coefficient?
Watt per meter square Kelvin.
Okay. So tell me, what is the highest rate of heat transfer? Means which mode has the highest rate of heat transfer?
Yes, sir. So, sir, solids have highest mode of heat transfer.
Solids have the highest mode of heat transfer. How?
Yes, sir. Sir, because by heat transfer by conduction, if we see conduction, sir, conduction, what happens? The transfer of heat takes place by molecular vibrations. Molecules are in their place, and heat is transferred gradually from one point to another. And sir, solids, the molecules are compact and packed. That's why, sir, the thermal conductivity of solids is more, and consequently, heat transfer in solids are more.
Do you know any material which has the highest thermal conductivity?
Highest thermal conductivity. Yes, sir. Highest thermal conductivity is copper and
How much is
aluminum.
that?
How much, sir? I don't know the exact value, but I have studied it's copper and aluminum.
Okay. ठीक है. What do you know about the effectiveness of an heat exchanger?
Effectiveness, yes, sir. Effectiveness, I know.
बताइए.
Yes, sir. Effectiveness is the ratio of actual heat transfer to the maximum possible heat transferred. It is basically a function of NTO and capacity ratio of the heat exchanger.
What do you know that phase boiling curve?
Sir, can you please repeat once?
Phase boiling curve. Phase boiling curve.
Phase boiling curve, yes, sir. I have heard about it.
What are the different phases, you know?
Yes, sir. One is, sir, first is onset of nuclear boiling, then pool boiling, convection, then nucleate boiling, then pool boiling, and the final stage is, sir, film boiling.
फिल्म बॉइलिंग आपने देखा है, घर में देखा है?
Sir,
घर में आप पानी बॉईल
experiment.
करते हैं, आपने कुछ ऑब्जर्व किया है इसमें? कुछ क्या फेज होते हैं
Yes,
boiling?
yes, sir. When we boil the water, sir, we see that continuous bubble formed, like continuous bubbles are formed.
Okay. ठीक है. Have you heard about Mach number?
Mach number?
Yes.
Yes, sir.
What does it signify?
Mach number is used in sonic and subsonic flows, sir. Basically, it is the ratio of inertial force to elastic force. If, sir, Mach number is greater than 1, it is supersonic. If it is less than 1, it is subsonic. And if it is equal to 1, it is sonic.
What is sonic? What is the speed of sound?
Speed of sound is 332 to 340 meter per second.
Okay. And do you know about this different types of fluids, Bingham plastic fluid and this Newtonian
Yes,
fluids?
sir.
What is the difference between a Bingham plastic fluid and a Newtonian fluid?
Yes, sir. Sir, Newtonian fluid is basically the rate of shear stress is directly proportional to shear strain. And in Bingham plastic fluid, although the law is almost same, but initially we have to give us little amount of stress. Like at zero shear strain, there is little shear stress. When we give it, then only then strain then shear initial like yield stress is there in Bingham plastic.
Acha, okay. You know Macap-Thiele method?
Yes, sir.
Okay. Can you tell me about its assumptions? Constant molar flow.
Yes, sir. Constant molar overflow. And sir, the liquid at a particular section, like in stripping section, the liquid flow rate and vapor flow rate constant. Liquid flow rate remains constant. If I from point of view of liquid flow rate, and in where the rectifying section, it is constant. I mean to say that at a particular section, both the flow rates remain constant, and the difference is the entry point in feed which we give.
Means flow is not, you can't say flow is constant. You can say the moles which are evaporating, number of moles
Yes,
which
sir.
are evaporating, the same number of moles are condensing moles.
Okay.
That is the single line answer. Okay. Constant
Yes,
flow.
sir.
So why that constant molar flow, that flow should be constant for the all column. Why it is different for rectifying? Why it is different for stripping?
Sir, it is different because because the difference is basically the feed flow rate which we give.
Yes.
That's why the difference is that's the difference, sir.
Okay. Now tell me about this minimum number of plates.
Minimum number of plates. Yes, sir. When infinite reflux ratio, then the number of plates are minimum.
What do you mean by the infinite reflux ratio?
Yes, sir. Infinite reflux ratio or maximum reflux is when the stripping section operating line and rectifying section operating line coincide with the equilibrium line. And sir, in infinite reflux, there is no feed. There is no feed. We put no feed to the distillation column, like it is independent. No product is withdrawn, and no feed is put into the distillation column.
Okay. ठीक है. बढ़िया है. ये क्वेश्चन मैं एक और पूछूंगा आपसे.
Yes, sir.
Can you tell me about the refrigeration cycle?
Refrigeration cycle, sir, I am little. I didn't study that, but little in thermodynamics it follows.
Yes.
I know that it is from second law of thermodynamics, but in detail I cannot, sir, explain it properly.
नहीं, ठीक है, कोई नहीं, आपको कुछ पूछना है?
Sir, how was my performance and how can I improve myself?
आपका परफॉर्मेंस अच्छा था, ठीक है।
Okay,
आपको
sir.
जो जो भी पूछा आपने अच्छा टेक्निकल आंसर दिया, ठीक है।
Okay, sir.
मतलब ऐसा नहीं था कि मुझे इंटरप्ट करना पड़ा, ऐसा कुछ नहीं था, आपने अच्छा टेक्निकल आंसर दिया,
Okay.
ठीक है। अच्छा तैयारी है, इसको ऐसा कंटिन्यू रखिएगा, ठीक है।
Yes, sir. Sure.
थर्मोडायनेमिक्स मैंने आउट ऑफ द वे जाके पूछा था, ठीक है। इट इज
Okay,
नॉट
sir.
रिक्वायर्ड, अगर आप ये बोले दैट योर आंसर इज आल्सो गुड ओनली, ठीक है, कि आई हैव
Okay.
हर्ड समथिंग इट इज रिलेटेड टू दिस बट आई एम नॉट रिकलेक्टिंग, यू जस्ट से आई एम नॉट रिकलेक्टिंग, ठीक है।
Okay, sir. I
इंट्रो
will
पे,
tell it.
हाँ ठीक है, इट्स ओके। इंट्रो पे थोड़ा सा क्या है, थोड़ा सा उसको स्क्वीज करना है, ठीक है,
Okay.
ठीक है, और उसको थोड़ा
Okay.
लिख दीजिए, ठीक है।
Okay, sir. Sir, what I
यू
will.
राइट इट डाउन,
Okay, I will write it out.
राइट इट
Okay.
डाउन, ठीक है, एंड मेक इट फॉर 8 और 9 लाइंस का आप बना दीजिए,
Okay.
अदरवाइज इट्स गुड।
Thank you, sir.
ओके, बेस्ट ऑफ लक।
Thank you very much, sir.
Recording stopped.
और कोई है? और कोई है?
Yes, sir.
हम्म,
Sir Rudraksh.
हाँ, तुम्हारा दिख नहीं रहा है यार, कैमरा ऑन करो। हाँ, बताओ।
Yeah. Good evening, sir.
हम्म,
Can I begin with my introduction?
यस यस प्लीज, थोड़ा सा तेज बोलना है।
Yes. Good evening, sir. I am Rudraksh Rajput. I have pursued my BTech in Chemical Engineering from Maulana Azad National Institute of Technology, Bhopal. I am currently placed at Reliance Industry Limited as a GD in Nuclear Energy Division. And I have done my project on the topic fabrication of novel porous membrane using fly ash, choline, and dolomite. I have also done a summer internship at Bureau of Indian Standard, Faridabad branch office as a quality assurance officer, and I have done my vocational training at Indian Oil Corporate Limited, Mathura Refinery under the unit Primary and Optomex. Apart from my academic career, talking about my co-curricular activities, I have been a part and the designer head of IST SC Managed Society, which lead to my hobbies. My hobbies are drawing, sketching, and graphic design.
Okay, in which department you are working in Reliance?
The nuclear energy department.
Nuclear energy.
Yes.
Okay, what do you know about nuclear energy? Means,
Sir, actually, it's a new department that they are forming in Reliance, and um, in coming years, government is gonna privatize nuclear energy. So Reliance is looking forward to develop an NPP of their own, and for that, new team has been developed. So
do
in
you know
nuclear
about this fissile material or fertile material? What are fissile materials? What are fertile materials?
yes, sir.
Fissile material, fertile materials, you know?
Yes, the fissile materials are those materials on which when neutron react, neutron can react. It can cause the fission reaction.
Which is the first fissile material we know? You know?
Yes, sir. U-238 and U-235. U-238 is not a fissile material. U-235 is a fissile material.
Then what will happen if a neutron strikes in fissile material?
Sir, it will form if one neutron strikes at a
Okay. Yes.
yes, sir. If one neutron strikes a molecule of U-235, it will, on an average, it will give 3 neutrons, and those 3 neutrons will, and along with energy, some amount of energy it will release, and that energy is what we are looking for. We are harvesting that energy to produce electricity.
Okay. So what are other organizations working on this nuclear energy?
Sir, MPCIL is currently working on the NPP of India.
What are the plant name of the plant? What technology they are using? You know.
Sir, there are reactors like LWR, PHWR, which are currently in use.
So whether they are using LWR or PHWR?
Sir, in older refineries, I think LWR are there, and PHWR is in new refineries. In
PHWRs are?
power plant.
No, PHWRs are used or not used in India?
Yes, sir, they are used.
ठीक है. Other subjects, you know?
Yes, sir. My favorite subject are heat transfer, mass transfer, and fluid mechanics.
Fluid mechanics. Fluid mechanics में आप ये बताइए, do you know bulk modulus of elasticity?
Yes, sir.
क्या होता है?
Sir, bulk modulus of elasticity is the ratio. Yes, the bulk modulus of elasticity is the ratio of change of volume with respect to volume.
What does it signify? If a fluid has a higher bulk modulus of elasticity, and what does it tell you?
If it has a higher bulk modulus of elasticity, that means with a small change in volume, sir, I'm not sure what will be this.
Okay. Tell me, you know laminar boundary layer thickness and this, how you define laminar boundary layer? Why boundary layer is formed?
Yes, sir.
Why a boundary layer is formed in pipe?
Sir, boundary layer is formed because the pipe acts as a resistance, and the layer which comes when the fluid comes in contact with the pipe, the layer and that is in contact with the pipe have velocity no slip condition. So at that point, velocity will convert to zero, and the momentum will get keep on transferring. So as the momentum keep on transferring because of the viscosity, as it is a cohesive force. That's why. Some momentum will be transferred and some momentum will be consumed as a resistance. So that's why boundary layer will get formed.
So it is good to have this boundary layer or not?
Yes, sir.
Is it good to have a higher boundary layer or not?
It is good to have a higher boundary layer. Sir, if a higher boundary layer is there, that means more turbulency will be there. And
if there is a high boundary layer, then
no,
when
that
does it
means
move?
there will be more laminar flow will be there, and yes, sir. So we want if turbulence is there, so more losses will take place. So that's why we want higher boundary layer in fluid.
Okay. What is surface tension?
The surface tension is the property of fluid in which the molecules which are attracted by the surface molecules which have some of the energy left, they attract each other and cause a tension on the surface. So that thing is called surface tension.
Do you know formula of it?
Yes, sir.
क्या होता है?
Force upon length.
F by L.
Yes, sir.
ठीक है.
No.
Anything you want to ask?
No, sir. No, sir.
ठीक है, बढ़िया था, अच्छा किया है, ठीक है. और थोड़ा सा इंट्रोडक्शन थोड़ा सा लंबा कर लो, बहुत शॉर्ट इंट्रोडक्शन, ठीक है. न्यूक्लियर एनर्जी में काम कर रहे हो तो जितना बेसिक होना चाहिए उतना बेसिक नॉलेज है, तो कोई दिक्कत नहीं है, ठीक है. और ऑर्गेनाइजेशन के बारे में पढ़ा है तो ऑर्गेनाइजेशन के बारे में पढ़ लो, आईओसीएल के बारे में पढ़ लो, ठीक है. और एक ये तैयार कर लो, मे बी समवन कैन आस्क कि न्यूक्लियर एनर्जी इज द फ्यूचर, ठीक है, देन व्हाई यू आर ऑप्टिंग फॉर दिस ऑयल इंडस्ट्री. ठीक है, तो इसका एक अच्छा बढ़िया सा आंसर तैयार कर लो, ठीक है.
सर कैसा था, मतलब
अच्छा था, मतलब ठीक है, मतलब बेसिक्स क्लियर है, ठीक है, और एक्सप्लेन भी कर पा रहे हो, अच्छा है, कॉन्फिडेंस भी अच्छा है. बस इंट्रोडक्शन थोड़ा सा लंबा कर लेना है, ठीक है. और एक क्वेश्चन तैयार कर लेना है कि व्हाई यू वांट टू लीव द रिलायंस, ठीक है. एंड सेकंड क्वेश्चन इज, सेकंड पार्ट है उसका कि न्यूक्लियर एनर्जी जब बोल रहे हो कि इट्स द फ्यूचर ऑफ एनर्जी, देन व्हाई यू आर लीविंग द न्यूक्लियर एनर्जी पार्ट। ये दो का एक आंसर तैयार करके ओके है, बाकी कोई दिक्कत। हाँ ठीक है। और कोई है?
सर एक डाउट पूछ सकते हैं सर?
हाँ, स्क्रीन पे आके
सर
बताओ यार, स्क्रीन पे
यस
आ
सर,
जाओ पहले, कौन है?
यस सर।
हाँ।
गुड इवनिंग सर।
हम्म।
सर डाउट ये था कि अभी इंटरव्यू तो शेड्यूल नहीं हुआ है, मेरा मेरा थोड़ा लेट में है।
सुनाई नहीं
मैं
दिया
ये
मेरे को,
जानना
क्या
चाहता
बोल
कि
रहे हैं?
सर तो उनके आंसर्स तो मुझे, जैसे मैं सर अभी आ रही है आवाज?
आपके
हेलो।
नेटवर्क वीक है, हाँ बताइए। हाँ।
हाँ सर मैं ये कह रहा था कि अभी क्या है, जैसे आप कोई भी क्वेश्चन करते हैं तो उसके आंसर्स तो मतलब रहते तो है माइंड में, लेकिन अगर बाई चांस अभी कभी इंग्लिश में उतना अच्छे से एक्सप्लेन ना कर पाए तो वहां पे हिंदी यूज कर सकते हैं?
हाँ मतलब एक्चुअली क्या है, देखो, इंटरव्यू के जो मन में आंसर है, ठीक है, 90-95% अपन हम लोग वो आंसर नहीं बताते हैं, ठीक है। मगर इफ यू आर गोइंग इन द राइट डायरेक्शन, ठीक है, दे विल कंसीडर इट,
यस सर।
ठीक है। नो वन, कोई भी ऐसा, देखो, दिस इज नॉट अ
यस
रिटन एग्जाम, ठीक है, दिस इज मैन टू मैन इंटरेक्शन,
यस सर।
ठीक है। तो अगर वो आपको समझ लेगा ना, इफ यू आर गोइंग इन द राइट डायरेक्शन, ठीक है, देन आइदर ही विल हेल्प यू और ही विल कंसीडर योर आंसर। तो इसमें कोई इशू नहीं रहता है, एग्जैक्ट वही आंसर चाहिए है। दिस इज नॉट बेसिकली इंडस्ट्रियल इंटरव्यू, they just want to know your approach, first thing, and second thing, whether you know or not, ठीक है। दे आर नॉट लुकिंग फॉर द करेक्ट आंसर्स, ठीक है। तो इसमें कोई दिक्कत नहीं है, बस ये जो भी बोलना है सोच के बोलना है बस, ठीक है।
यस
और
सर।
तीसरी चीज ये है कि कोई भी अगर कोई चीज नहीं आती है, ठीक है, कोई चीज में हमको नहीं मालूम है, तो वहीं पे हमको बोल देना कि सर ये नहीं मालूम, या ये पता नहीं है मुझे, या मैं पढ़ लूंगा, या भूल रहा है, ठीक है। अपने से मन से बना के आंसर मत देना, क्योंकि वो वहां पकड़ के फिर वहां खींचेगा, ठीक है।
यस सर। यस सर, थैंक यू।
ओके।
थैंक यू सर।
और है कोई?